Hi, biochemistry students. Hey, let's take a look at Unit 7, Stoichiometry. So what does that mean? So as we look at our slideshow here, it literally means the process of measuring the elements. And so here is where chemists and biologists have developed a tool that allows for them to determine how much is happening in chemical reactions, accounting for the masses. Okay, so that could be like if you started with a certain amount of mass of a reactant, then they might ask, well, then how much product would be produced? And so that's really kind of the skill that we're going to be emphasizing here and trying to learn in Unit 7. And so it's about the mass relationships, and that's kind of what this slide is talking about, how much and so forth. Now, the the types of problems that you might run across, the best way to learn this is just to put pencil to paper. And, so like anything I'm asking you to do on Canvas where I have you submit it electronically, the best thing really that you can do here is just work it out on paper and then transfer it to the document and submit it. But sometimes problems involve like solving for what's given here in the type 1 that you see listed here, where what may be given in the problem is the number of moles of a reactant, for example, and then it's asking you to solve for the number of moles of the product. Now, these are the type of problems that we've already done in Unit 6, so those should be somewhat familiar, but as you progress and continue to build your skill set for chemistry, then you can move on to things like type 2 problems where you're given a mole amount of the reactants and then you're asked to find the mass that would be produced. So in these types, what that's referring to is that it's just kind of what you start with and what they're asking you to solve for. Finally, the ones that we'll probably put the most emphasis on are the type 4 problems, where you start with a mass and then you're able to predict with knowing the mass of the reactant. Then you'll be able to know what the mass of the product in question that you're solving for would be. Okay, so that's the idea on that. Okay, so let's look at mole ratio. We've already been working with this, so you should be familiar with this. It's really about creating a conversion factor. So like if we look at this balance equation where we have iron and oxygen and we have iron oxide being produced, and this is a synthesis reaction, then what would the mole ratios be? Okay, so if we're comparing iron to oxygen, then it would look like this. So we could say, well, there's 4 moles of iron for every 3 moles of oxygen. But it has to always start with a balanced equation. So, what you want to do is you want to make sure we get the balanced equation. You want to make sure that if you are creating a compound here, like in this synthesis reaction, where we're taking iron and combining oxygen and we're making iron oxide, you want to make sure that that iron oxide compound is correct and so forth. But so when you create these conversion factors, the purpose of that is so that when you solve a problem, that you end up with the correct unit. So like in the first one here, 4 moles over 3 moles, then since 4 moles of iron is on top of the conversion factor, then that's really the unit that you're going to end up with, because most likely you're going to be setting the problem up so that you can cancel out the units that you're needing to cancel out. So let's look at some other examples here. You can look at just different versions of the same equation there. And so they're just showing you all of the different versions of that. Okay. Now, here is an important concept that we're heading into, and that is molar mass. Now, here's an example of a compound, aluminum oxide. Okay, so how do we determine the molar mass of that? So notice there's 2 elements, atoms of aluminum, and so when we look at the periodic table, we see that 1 aluminum is 26.98. That's its atomic mass, and we have 2 of them. So we're trying to account for that. So we do that again for the oxygen and add them up. Okay, I hope this helps. And